I was able to do. Yeah, so many. But one of my answers was graph on calculator, and I didn't put my answer down. We should have a plan. Yeah, we just that part of the video. I skipped literally like 3 minutes of the video because it was just you guys talking about it.
I think I was passing stuff back during that time, but yeah, that was.
God, it was so funny. But I know I did it too. My math binder is about to break. I don't know if you look at it. I need a binder, notebook that has taught. Actually, it's what I'm being. Oh, wait, it's not easy.
So this one, we need to use U-Substitution. Right? On this one, we should be able to recognize a function and a multiple of its derivative. Right? So if my u is x cubed minus 1, take the derivative of that, I would get 3x squared, but I just want it to be 1x squared, so I would need to multiply both sides by 1/3. Then I could set up my U-Substitution, so I would have u to the 10th power times 1/3 du. We can just pull that 1/3 out front. Then the antiderivative of u to the 10th is 1/11th u to the 11th. Multiply that by 1/3, we would get 1/33 times u, which is x cubed minus 1 to the 11th power, plus c. So D would be our answer for this one. All right. We okay with that one? Maybe. Yeah. All right. How did the homework go? It's fine.
You know, I tried.
Okay.
I think I got messed up on the algebra.
Okay, so you felt good setting up the integrals, but then like after that it wasn't too solid. Well,
I
let's.
just don't know if I even did like the setting them equal to 0 rate and then getting that calculator. I should have gotten a normal number and then I did. Like I ended up getting radicals and stuff.
I think on one of them you would get radicals. So here, I'll just run through the answers real quick, and then we can see which ones we want to go over in some more detail. So 2 was 32/3. 4 as an exact answer is 8 radical 3. I don't know what that is as a decimal if you put that in the calculator. 6 is also 32/3. 8 said to use your calculator, so this one was 1.237. 10, again, another calculator one, 4.807. And then 12, this 12 was pretty tricky. This one ended up being 215/6. All right, so which of these do we want to talk about?
I have 10.
10? All right. Okay. We can take a look at 10 here. So on this one, it says that we want to look at the region between these two curves on the interval 0 to pi. And it says to use a calculator. So if we graph both of these functions, okay, we would end up with some kind of picture like this. So we end up with 3 different pieces that we want to look at here. On this first piece, and again, we can use the calculator to find this x value, to find this point of intersection. And if we do that, I think we end up getting that it's 0.375. So on this first interval, from 0 to 0.375, the cosine of 2x function is greater. So I need to split this up into three pieces, right? So the first piece would be 0 to 0.375 of the cosine of 2x minus 2 sine of x. Then the next piece, and again, we're using the calculator to find this point of intersection. And when we do that, I think we should get 2.767. So the second piece, my second integral, will go from 0.375 to 2.767. And on this piece, the 2 sine of x function is greater. So I would say 2 sine of x minus cosine of 2x on this interval. And then the third piece, okay, they flip again, right? So the cosine of 2x function is greater. So here, I'm going from 2.767 up to pi. And this time I'm doing cosine of 2x minus 2 sine of x dx. Okay, so I would need to add all three of these integrals together because the top function changes, right? So I need to split this up into three pieces, add all three of those together to get 4.087. So, I mean, we looked at some examples of where we would need to split up into multiple integrals, where the top function changes. We okay with that setup? Right, and again, on something like this, I mean, you're not going to be asked to do all this by hand, right? We can use the calculator to find the points of intersection, which are our bounds. And then we can even use the calculator to determine which function is greater on which interval. No other questions on that one? All right, what other questions do we have on the homework? Sure. So on this one, we have both of our equations are already solved for y, so we're good there. So if we're doing this by hand, the first thing we need to determine is our bounds, right? So I would need to set these two functions equal to each other. So x squared plus 2x plus 1 equals 2x plus 5. To solve this, I would get everything on one side equal to 0, so I'll subtract both of these things over. So the 2x's end up canceling, and we just get x squared minus 4. So this is pretty easy to solve. Right? It's a difference of squares. So we get that these 2 points of intersection are -2 and +2. So those, that's where it was. So those are going to be my bounds, right, on my integral. -2 to 2. So then the second part is determining which function is greater on that interval. So I need to pick some value in between -2 and 2 and plug that into both functions. So 0 would probably be the logical choice here. If I plug 0 into the quadratic, I would get 1. If I plug 0 into the line, I get 5. That means on the interval -2 to 2, the line, the linear function, is greater. So when I'm setting up my integral, the linear function is going to go first. I'm going to do, the bigger one minus the smaller one. So in this case, that's the linear function minus the quadratic. Then I can combine my like terms and take the antiderivative. So the 2x's again would cancel, and we would just end up with the integral from -2 to 2 of 4 minus x squared. So then this is actually a pretty straightforward one to do by hand. Right? Then we can take the antiderivative of each piece, get 4x minus 1/3 x cubed, evaluated from -2 to 2. So then we're just plugging in 2 and -2. So 4 times 2 minus 1/3 times 2 cubed minus 4 times -2 minus 1/3 times -2 to the third power. So 8 minus 8/3 minus -8 plus 8/3. So we end up with, let's see, 8 plus 8 is 16, -8/3 minus 8/3 would be -16/3, so 16 minus 16/3 would be 48 minus 16/3, so 32/3.
Can you say number 4?
Yeah.
That's all.
Okay. Cool. Yeah, your bounds would have been negative radical 3, positive radical 3. Yeah, I don't like how they did this using symmetry. Rather, you just make your bounds negative radical 3 and negative radical 3. Any other questions on the homework? Feel okay with finding area between two curves? So, I mean, it's just find your bounds, which means where the curves intersect, unless you're given some other information, and then figuring out which one's greater and subtracting bigger one minus smaller one. All right. Today, then, we are going to start talking about how to find volume. So volume is the final idea of AP Calc. We are gonna take a look at a few different ways to find volume, but we are starting the final idea here.
Wait, so this is the last thing we're learning in AP Calc?
Yes. I mean, again, this is going to last up through the end of next week, but
We're really not that far behind.
no. I mean, as long as we can actually finish everything by the end of next week, I think we'll be in a good place.
When's that
Right. Yeah. So I want to finish everything by next Thursday, so that we're done. We have all the material done by the time we take the practice test on the 23rd. Then we'll have about 3 weeks to review.
Do you see what we get on the practice test?
Well, so your homework that night is going to be to grade your own test. Like, I will give No, you cannot get a 0. I'll give you like the answer documents and everything, and your homework will be to grade your exam, and then we'll talk about it, the next day.
What are we doing for this test? Like, if you
I think we're gonna do like a take home test. All right.
I'm not sure.
Can you just specify that we're allowed to use calculator?
Yeah, I did a poor job of that on the last one. Yes, I will do a better job of that on the next one.
I like where you do that.
I got you, Sharon.
There
Why did geometry come back in calculus?
Well, my class next year is analytical geometry calculus.
Well, that's your class, not my class.
It is now.
You can give this after.
I'm gonna be so bored next year learning how to take a derivative.
In my hand.
Alright, so today we are going to start looking at how to find volumes of really weird looking objects. We need to understand though how to find areas. Okay? So it's going to be really important that we understand what we just did to do this new thing, to find volumes. The first way that we're going to look at finding volumes is if we know what the cross-section looks like. So if you look on the right side of your paper, it kind of gives a visual of what we're doing. So like we're going to find the volume of a figure that looks like this, okay, where the base is this region here, and then all of the cross sections are squares. So this is kind of a weird visual, but if you think about, there's an infinite number of squares. They're not spaced out like this. So every cross section that we take would be a square. Okay, that's the type of object that we're going to be finding the volume of. Or we could find volume where we know that each cross section is a semicircle or a triangle or a rectangle. So to do that, first we want to remember what our area formulas are. So what is the area of a square? Side times side, right, or side squared. Now, rectangles are also fairly common that show up on something like this. So, a lot of times if you see a rectangle problem, it'll say like the height of the rectangle is twice the base or 3 times the base or something like that. Right? That's it's kind of a rectangle. So what's the area of a rectangle then? If I say this is like length and width, length times width, right? How about of an equilateral triangle? What is it?
Why am I only thinking of base times height?
It's like
Well, yeah, the area of a triangle is base times height, but let's say that we only know this side. Say it again. Base squared divided by 2. So that's going to play a part in this. So I need to figure out the height, right? Because we know that the area of a triangle is 1/2 base times height. But if all I know if all I know is the base, how can I write the height of an equilateral triangle in terms of the base? Yeah, we can use a right triangle. Okay? So if this is equilateral, I also know that these sides are the same length as the base. Right? So how can I write then, or how can I use this equilateral triangle? How can I use this right triangle?
1/2 b plus 8.
Yeah, we can just use the Pythagorean theorem, right? Because I know I can split this up. If I draw this right triangle, I can say that each of these will just be 1/2 of b, or b over 2. So then, if I'm solving for this side, we can call it h, but our goal is to write it in terms of b. I can say that so now what? Yeah, so I would subtract this over, right? And I could go ahead and square this. So I'll do that in one step. We could say this would be h squared is b squared minus, if I square both the top and the bottom, I would get b squared over 4, right?
Square root.
Wait, say that again? But I want us to derive it. So, well, first, these are like terms, right? I can combine these. Yes. Yes, they are. So, yeah, this would be like 1b squared minus 1/4 b squared. So 3/4, right? I would get h squared equals 3b squared over 4. And now we can take the square root and get h equals, now we could clean this up a little bit. So if I'm taking the square root of each piece, right? So we can say square root of 3, and then if I take the square root of b squared, that's just b over 2, right? The square root of 4 is 2. So I can say that my height is the square root of 3 over 2 times b. For an equilateral triangle, yes. So I can rewrite this as 1/2 times b times the square root of 3 over 2 times b. So can I clean that up a little bit more? So I can multiply the coefficients together, right? You get, so this is our area formula for an equilateral triangle. Square root of 3 over 4 times the base squared. All right. You okay with that one? Okay, that's really the only complicated one. Okay, how about an isosceles right triangle? Isosceles triangles are also yes, and so if we know it's isosceles, we know these two sides are the same, right? So if we call this side B, we could also call this side B. Right? If it's isosceles, those two sides would be the same. So if, I mean, you know, area of a triangle is 1/2 base times height, but we're saying that the height is also the same as the base, right? So it'll just be 1/2 b squared. All right, and then finally, a semicircle. 1/2 pi r squared. Now, when we're doing this for this type of problem, we'll generally be given diameter, okay, or the base, right? So if we want to write our formula in terms of the diameter, we would say that the area is 1/2 pi r squared, but in terms of d, that would be d over 2 squared, right? The radius is the same as half of the diameter. So 1/2 pi r squared would be the same as 1/2 pi times 1/2 of the diameter squared. Right. You okay with area formulas? All right. So let's do some calculus then. All right. I guess first, we want to think about now writing a formula in terms of the area of one of these cross sections. So if we look back at the top of the left side of the page there, it shows us the formula for finding the volume of one of these figures. Okay? I want to take the integral of the area formula that we're looking at. So I want to take the area of one of the cross sections and integrate that over whatever interval that I care about. So here, on this example, if I'm told that cross sections are taken perpendicular to the x-axis, what I'm looking at is the squares have a base that's the difference between those two curves. So if let me kind of draw this on a two-dimensional plane here. So we've got something like this, and then like this, right? So I'm saying there are squares coming out of the board, right, that are perpendicular to the x-axis. To find the area of one of those squares, well, the base of one of those squares is this height. It's the difference between the two curves. So to get that length of one of the sides of the square, I'm just going to take the top function minus the bottom function. Right? So here we're calling this function f of x and this function g of x. So the area of one of these squares, okay, if I'm saying that the length of one side is f of x minus g of x, I guess you tell me, what would the area of that square be if one side is f of x minus g of x? Yeah, the area of the square. Yeah, just square that, right? F of x minus g of x, that quantity, squared. So we can say that a of x, my area formula for this square is just f of x minus g of x squared. Okay. Now, if I want to set up an integral for that, to find the volume of that figure, I'm just going to take this f of x minus g of x squared and integrate that over whatever interval they tell me to. So sometimes, just like we did for area, we would have to find these points of intersection. Okay, here for our generic purposes, we're just calling these values a and b. Okay, so to set up and find this volume, I would take the integral from a to b of f of x minus g of x squared. So I'm taking the integral of an area. Okay, this formula is the area of the cross section. It's a square. So the integral of this area will give me the volume of this figure. Okay. Similar idea if we're told that the cross sections are semicircles. Okay, and for problems like this, we will always be told what the cross sections are. Okay, we'll be told the cross sections are squares, or we will be told the cross sections are semicircles. Okay, so if I have a picture just like the last one, just like this, but now we're told the cross sections are semicircles, I want to first write an area formula. So here I know this difference, right? The diameter of this semicircle is the top function minus the bottom function, f of x minus g of x. So how can I write a formula for this area of the semicircle knowing that this length, the diameter, is f of x minus g of x?
Divided by
So yeah, to get the radius, we would say this is f of x minus g of x over 2. So that's the radius of this semicircle. Right, square that, multiply by 1/2 pi. So 1/2 pi r squared. Right, this would be the radius of that semicircle. So then, to find the volume of this figure, we would just integrate that area function. So integral from a to b of, and we can actually just go ahead and pull that 1/2 pi out front. This 1/2 pi is just a constant. So I can pull that out front and say this is 1/2 pi times f of x minus g of x over 2 squared dx.
Will these most likely be calculated problems?
So, yes, more than likely these would be calculator problems. Some questions like this have shown up on the non-calculator portion, but when that happens, most of the time all they ask you to do is write the integral, but do not solve it. And we'll take a look at a bunch of examples of that next week, probably, like how it actually shows up on the AP test. All right, you okay so far? All right, so let's do the same thing then for isosceles and equilateral triangles. So first, again, I'm told that the area between this region, okay, the cross sections coming out of the paper or out of the board are isosceles right triangles. So that distance between the two functions, f of x minus g of x, is the base of my isosceles triangle. So how would I write this area? How would I express the area of this isosceles right triangle? X minus g of x squared, all of that over 2 or times 1/2, either way. So if I want to find the volume of this figure that we've created, take the integral of that area. So I can pull that 1/2 out front. So 1/2 times f of x minus g of x squared dx. Don't forget your dx. So finally, we have an equilateral triangle. And we know that the base of this equilateral triangle is f of x minus g of x. How could I express the area of this? Yeah, so we'll just have square root of 3 over 4 times f of x minus g of x squared. And again, to turn this into a volume formula, we would just take the integral of that. So I can pull square root of 3 over 4 out front times f of x minus g of x squared dx. Questions so far?
All right, let's actually try an example here then. All right, so the first example
says find the volume of the solid whose base is bounded by the square root of x and x equals 4 and the x-axis, and each cross-section is a square taken perpendicular to the x-axis. Okay, so for at least these first couple, let's sketch out what's going on here. Okay, we don't always have to make a sketch, okay, but I think it's helpful to kind of see what's happening. Hopefully we know what these functions look like a little bit. And so the square root of x does something like this, right? X equals 4 is a vertical line at 4. And then the x-axis. So we're taking a look at this region right here. So we know that this point is 0, 0. Right? Where would this point be? The point where x equals 4 and the square root of x intersect. at, yeah, I think it would be 4, 2. Right? So if we need to, if we can't see that right away, we could just set the square root of x equal to, we could set, right, we're just taking the square root of 4, since we know that we're at x equals 4. So we would end up with y equals 2. So now, what we know is that each cross-section, so cross-section meaning I've got squares coming out of the board like this. Each cross-section is a square here, taken perpendicular to the x-axis. So first, I want to express my area of each of those squares. How would I do that? And we can also, here, let's sketch out a square. Right? Here's my cross-section, here's a square. Right? So I'm saying that the base is this. How would I express the base of that square?
Base squared.
So yeah, the area would be base squared. So what is the base? How would I express the base here? So the top function is the square root of x. What's the bottom function? 0, right? It's the x-axis. So I would just have the square root of x minus 0. So I can just say that this base of the square is just the square root of x. Well, that means that the other side is also then obviously the square root of x. So the area of this square is the square root of x squared. It's just x. So if I want to find the volume of this figure then, I'm going to take the integral. What will my bounds be? 0 and 4. So the volume from 0 to 4, and my area, the whole function, the area function is just for x. Right? So this is the integral that will get me the volume of this figure. So this is really easy to do by hand. The antiderivative of x would be 1/2 x squared. Evaluate that from 0 to 4. So plug in 4 and plug in 0. So we get 8. You okay with that one? That one's pretty straightforward, right?
We probably have time to do one more here. So the second example says find the volume of the solid
Whose base is a region bounded by the circle, with the cross sections taken perpendicular to the x-axis as isosceles right triangles, with the hypotenuse lying on the base of the circle. So what's going on here?
So we have a circle.
We have a circle. What does this circle look like?
It has a radius, a diameter.
So what's the radius of this circle?
Oh,
3. Right? This would be a circle with a radius of 3, centered where? At 0, 0, at the origin. Right? So we've got a nice circle here, radius of 3. Obviously, I can't do that. Right? So we're told now that the cross sections taken perpendicular to the x-axis are isosceles right triangles. So cross sections are going from here to here, and it says the hypotenuse is lying on the base of the circle. So this is the hypotenuse, and we've got an isosceles triangle coming out of the board like this. So if I sketch my isosceles triangle, right, this hypotenuse is this side right here. How could I express that? So if we want to think about like top function minus bottom function. What's that? That would be one way we could think about it. We could think about splitting this up into two pieces. But we could also think about, well, in order to write this as a function, we would need to solve for y, right? So if I solve this for y, we would end up with y equals plus or minus the square root of 9 minus x squared. So what we're looking at here is this top semicircle is the positive root, and this bottom semicircle is the negative root. Right? We're thinking about this in terms of an actual function. So the difference between these two functions, right, if this one we're saying is positive root of 9 minus x squared, and this one is negative root of 9 minus x squared. Yep. If I do top function minus bottom function, it would be multiplied by 2, right? This would end up adding together. So this distance right here, we can express as 2 times the square root of 9 minus x squared. Now, from that information, how can I express the area of this isosceles right triangle? Would be, so, well, this is the hypotenuse, right? The base and the height would be these two sides. I need to solve for one of these pieces here. How can I solve for one of those?
The